Hello everybody, this is the notes for Advanced Geometry, section 4.2, talking about congruence and in the context of triangles. So, we've talked about congruent segments, we've talked about congruent angles, basically just means they're the same measurement. Now, when you start talking about congruent objects like triangles and congruent polygons, congruent figures, you got to have a bunch of things in place. And so this is the top definition. May as well just go ahead and take a second to copy down really all of this screen here. Actually, just copy down the top two parts. So, in two congruent figures, all of the parts, all of the sides, all of the angles, they got to be congruent to the corresponding parts in the other object, in the other figure. So, the corresponding angles got to be congruent, all of them. The corresponding sides have to be congruent, all of them. You got to have everything be exactly the same. Now, a congruent statement tells you which two objects are congruent, and it tells you which parts are corresponding. So a congruent statement is something like these down here. This triangle ABC congruent to triangle FED. That is a congruent statement. The order in which you list these things doesn't matter, but you have to be consistent. All right, corresponding vertices are written in the same order. So it's kind of color coordinated here. Vertex A and vertex F, those are corresponding because you look at this picture, angle A and angle F, they're congruent to each other. All right, vertex B corresponds with vertex E. Okay, B is second, E is second. They're the same color, but again, look at the picture. Angle B is congruent to angle E. So they're corresponding in these two congruent triangles. And lastly, vertex C corresponds with vertex D. They're both written last, so that's telling you that they're corresponding. Angle C's got the three arcs, angle D has the three arcs, so they're congruent. And if you look at the sides also, side AB in green, it's got the single dash, it corresponds to side FE. So the corresponding order, AB was first and second, looking back over here. AB was the first and second letters written, FE are the first and second letters written. So corresponding order tells you, or the order of these letters tells you what parts are corresponding. And we can go all the way around. It really doesn't matter. If I wrote segment AC, first and last letter, that's going to be congruent to segment FD without even looking at the picture, just going in the order of the letters. First, then third, first, then third. All right. So that's the idea of how these correspond, or these congruent statements work. All right, so in this example, you were given that two triangles are congruent. Triangle EFG is congruent to triangle OPQ, and we want to complete each of these statements. So for the most part, you don't even need to look at the picture. We're just looking at the congruence statement. Segment EF is going to be congruent to another segment, but EF, first and second letters. So go with first and second letters. So segment OP. Angle P. P is the second letter, so we got to go with the second letter. So that's going to be angle F. Angle G, that's our last letter in the first triangle, so we go with the last letter. So angle Q. Measure of angle O. All right. Angle O corresponds with E. Angle E is 110, so O has to be 110 also. So I'm going to put it in two ways. Measure of angle O is going to equal measure of angle E, which equals 110 degrees. Now, this notation for number 6, there's two letters, there's no dash or anything. We're talking about a measurement of a segment. So QO, that is the third and first letters in that triangle name. So we got to go with the third and first. So that's going to be GE. All right. GE we know is 7. So we could also just say this equals 7. All right. triangle GFE. All we're doing is just changing the order of the letters. So we just got to match them up. G was last, it corresponds to Q. Now it goes first. F was second, it corresponded to P. E was first, that corresponds to O. All right. Order matters in these letters, in the way that the congruent statement is written. All right. For this theorem, take a second, copy it down. This is an important one. So this theorem says that in two triangles, if you already have two pairs of congruent angles, we got angle B congruent to angle E, we got angle A congruent to angle D. If you've got two pairs of angles congruent, this third angles theorem forces that third pair of angles to be congruent to each other. Okay? Just a very simple, this is not a proof by any stretch of the means, but a very simple idea of this. Let me clean these up a little bit. This says if angle B was 100 degrees, angle A is 40 degrees. So that means angle E here is 100, angle D is 40. Well, what we talked about in section 4.1 is that the three angles of a triangle add up to be 180. That forces this angle to be 40 degrees also. With the 100 and the 40, it forces this angle to be 40 degrees also. There's the third angles being congruent. So if two pairs of angles are congruent in a triangle, the third pair of angles have to be congruent also. All right. You don't need to copy all this down, but we've seen some of these things before, so let's just talk about it. Reflexive property. Okay. Anytime you use reflexive property, you're saying something is congruent to itself. Or the other way around. When you say something is congruent to itself, you're using the reflexive property. For the symmetric property, basically that is just changing the order. Triangle ABC was first in this congruent statement, and now you're putting it second in the congruent statement. You're just switching the order. We very rarely use symmetric. We use reflexive property a lot, and we're going to be using it a lot more coming up, but not typically in this way. We don't really need to say a triangle is congruent to itself. We use it a lot with saying segments are congruent to themselves or angles are congruent to themselves, but not usually with triangles. Transitive property, we always use that all the time. We've talked about what that transitive property is. I hope everybody has a very good understanding of it. It applies to triangles also. Triangle ABC congruent to triangle DEF. DEF is also congruent to triangle JKL. That forces triangle ABC to be congruent to triangle JKL. Just transitive property, just applied to triangles. Okay, we'll do the examples in the next video. Please watch those. That's part of the notes, part of taking good notes, is seeing the problems thought through and worked out. So you have to watch them.